Welcome to solverfy.
In this question, we are looking at the alpha particle being bombarded towards a gold nucleus and to find how close they can get. So an alpha particle starts off very far away from our gold nuclei. I want to find what is the distance of closest approach, right, between the alpha and the gold particle. So at the initial stage over here, the total energy is just the kinetic energy of our alpha particle. At the distance of closest approach, we expect that the particles are at rest, right? They are not moving because all of the kinetic energy must have been converted into electric potential energy. So by conservation of energy, the total kinetic energy at the start, which is thus the kinetic energy of the alpha particle, must be equals to the electric potential energy. And we can calculate that based on the distance of closest approach. That is equals to 1 over 4 pi epsilon naught times Q of the alpha times Q of the gold nuclide divided by R squared. Divided by R. Where R in this case is the distance of closest approach. Now we know the kinetic energy is given to be 7.7 mega electron volts. We need to convert this into SI units, which is in terms of joules. Right, and now we can actually rearrange to find what is our R. So our R is equals to 1 over 4 pi epsilon naught times the charges. So the charge of alpha particle is 2 times of the elementary charge, so that's 2e. The gold particle, the gold nuclide has 79 protons, so that is 79e, where E is the elementary charge, so that's 1.6 times 10 power minus 19 coulombs. So we square this, divide by the energy, kinetic energy, which we have previously calculated. Epsilon naught is the permittivity of free space, that is 8.85 times 10 power minus 12, right? Put it into the calculator, we should get a value of 3.0 times 10 power minus 14 meters. So this is the distance of closest approach. Comparing it to the size of our gold nucleus. So the size of the gold nucleus, the radius, we use the formula that takes into account the nucleon number to the power of 1/3 times R naught. Right, where R naught is a constant of 1.2 times 10 to the power of minus 15 meters. Right, just an estimate. So there will be 197 to the power of 1/3 times 1.2 times 10 to the power minus 15. And we take the ratio of the distance of closest approach over the radius of our gold nuclide, we should get about 4.2. So the distance between the alpha particle and the gold nuclei when they are at the closest point is about 4.2 times the size of the gold nucleus.